I'm Betsy Lamb from New York State Integrated Pest Management.
I'm Neil Matson from Cornell Department of Horticulture.
I'm John Sanderson, Department of Entomology at Cornell.
And we're here today because we're going to talk about a research project that we've been doing both in the greenhouse and growth chambers at Cornell and in some commercial greenhouses.
One of the trends that we've seen, especially in the past 5 years, with increasing heating oil costs for heating a greenhouse, is that growers will really separate out cool crops and have different growing conditions and grow those crops under colder conditions. So talking to an entomologist and an integrated pest management person, we were talking about whether that would affect kind of the life cycle, the length of the life cycle of different pest organisms, and fungus gnats was one that came to mind. So we wanted to look at the effect of temperature in the growing environment on production and life cycle time of fungus gnats.
And then in addition, to see if BioControl, which types of BioControl that have been shown to work to control fungus gnats, would react the same way to temperatures or give you the same level of control under the warmer and cooler temperatures.
And one of the things that we found in the studies that we did in growth chambers, where we had very controlled temperatures, our coolest temperature was constant 55 degrees Fahrenheit, and our warmest chamber was constant 75 degrees Fahrenheit. And we found that fungus gnats were produced in about the same amount of numbers in the pots in these chambers, but they took about a month longer in the cool temperatures compared to the warm temperatures. So it didn't really slow them, it slowed them down greatly growing in cool temperatures, but they were still coming on. But we also overlaid that study with drenches of nematodes. Steinernema feltiae is the name of the nematode that we used. We drenched each replicate of the experiment that we did. We drenched 2 times, once every 2 weeks, and compared the numbers of fungus gnats that came out of those chambers compared with controls that received nothing. And regardless of the temperature, whether it was 55 or 75, we got pretty good control of the fungus gnats using nematode drenches.
So then we decided to take the same, or to try and do somewhat of the same experiment in commercial greenhouses. Of course, it's very difficult to get the same situation in a controlled situation in a growth chamber and in a commercial greenhouse. But the 3 houses that we worked with did use the drenches or the sprays of the Steinernema feltiae nematodes, and then we used sticky cards to see if we could see differences in the numbers of fungus gnats that were produced. This is one example for one crop, and you can see where the control was unsprayed, and this is the spray type. Now, I'm not sure that we can say that it works consistently for all the crops we tried and for all the situations, but at least it's a start to be able to take research done on campus and try it also in a commercial greenhouse.